Hello everyone. Today we are going to do a quick demo to showcase how can we work with JSON and array data structure in BigQuery. Um, Google BigQuery is pretty flexible in terms of a data structure that it can work with. And when you think of data warehousing systems, you have this concept of normalization and denormalization. Each one have their own pros and cons. So when you think of denormalizing things, you're trying to do a lot of duplication. So when you're trying to pull data, there are many duplicate field information. But if you're trying to do a normalized view, let's say if you are for your query, you have to go and pull data from multiple different tables, you will end up paying a high cost because your joins would be very expensive. So with that in mind, let us go ahead and explore what capability BigQuery has and how can we leverage that if we have JSON or array type of data structures. Let's go to BigQuery first. So if we go here, Big Data, BigQuery. So we'll create a new data set. And we'll name it as, let's say, fruit store. We'll keep everything else as default. Let's try to create that. So we have this food store data table created. We don't have any information here because we haven't loaded any kind of data here. So let's see. Let's try to create some data. So you created an array of fruits. So if you look at here, you have one element, but these are like different elements within the array. Now let's say if we had something like this, your data validation would fail. Now if you look here, you're getting the error message, array elements of type integer string do not have a common super type. So here you should have every element of an array, they should have a same element type. So obviously we would get that error. Now let's try to run another query. So what we are trying to do here, we are trying to get this information. We're trying to get person, fruit array, and total cost information from fruit store. So, okay, we had this information. We got, so if you look at the data, we have two person, Sally and Frederick. They have multiple array elements, and then they have one total cost. Now, if you go ahead and look at the JSON side of it, so for person, Sally, your food array has 4 different entries. Your total cost has a certain entry. Again, same for Frederick. You have fruit array, which has 2 entries, and you have total cost as 1 entry. Now, let's say we wanted to load this JSON file into BigQuery. So let's go ahead and create a new table. So we have this fruit type. We'll go ahead and create new table. We'll select Google Cloud Storage. We'll select GS bucket. So and we'll say it's a JSON type. Schema will say, let's keep it auto detect. We'll say fruit details table. Let's go ahead and create the table. So if you see here, if you look at the schema, you have your total cost. It's a floating type. It's a nullable mode. Your person is a string. It's a nullable mode. But the interesting part here is if you look at fruit array, it is string and it is repeated. Oops, not doing anything. So when we say repeated, repeated means it's an array. So the idea here is BigQuery, it natively supports array. All array elements should have same data type. Arrays, when you think in terms of BigQuery, they are called repeated fields. So that's how we think about arrays when we look at it from BigQuery standpoint. Now let's try to select few information from our e-commerce public data set. Let's see how we'll go, what do we get? So if you go here, you delete. You're trying to get some information from your e-commerce all sessions table. You have your visit ID, your SQL is valid. It is going to return 2.2 GB of data. Let's go ahead and run that. So if you go here, and if you look at the data, let's look at the job information first. So you have 2.15 GB of data. Your execution time was 0.7 second. Number of bytes that got shuffled was 11.99. Here you have your detailed JSON type information for your every data element. Let me pull up the results. And these are the results that we have from this query. Now let's take this a step further. Now we'll try to use aggregate array function to aggregate all the string values that we have into an array. Let's see how it works. So we are having this editor here. We are removing this. We are creating an aggregate of arrays. This again will return 2.2 GB of data. Now let's go ahead and run this data. Now let's explore this result. Now, if you look at the data, how many records are written? You have only 2 records returned. But if you see here, you have this product views and pages viewed. You have an array of strings. So for visitor ID ending in 8569, he viewed two products and he viewed two pages. He viewed Google RFID journal and he viewed Google Snapback had black page. Now let's look at the JSON of this records. So if you see here, you have this one user ID. He has product viewed and pages viewed. But if you look at this user ID ending in 569, he has viewed quite a few products. At the same time, he has viewed quite a few pages. So obviously, looking at this data, it is evident that user ending in 569 is more engaged with the platform. He's doing a lot of browsing and he's looking at a lot of products from the platform. Now let's try to create length to count number of pages and number of products that were viewed. So let us go back to our editor and come back here and try to do something really good. So if you see here, this one would also return 2.2 GB of data, because essentially, in addition to aggregating your product name and pages viewed, you're also trying to calculate the length of those titles. So let me quickly run this. And now let's hide our this thing. Now, so if you see here, by capturing number of product views and number of pages viewed, we can quickly get a high-level snapshot of how engaged a particular visitor is, and we can directly get a quantified value out of it. Now let's take this a step further and let's find distinct aggregates of array. We don't want to take into account duplicate visits or duplicate product views. So let us go back to our editor here. And now we are trying to say distinct page title as well as distinct product name. Again, this will return 2.2 GB of data. Let's go ahead and try to run this data. Let's hide our editor and see. Now, if you see here, for user ending in 569, initially he had viewed 109 products and he had visited 109 pages. But now if you look at the distinct products, it is evident that he looked at only 61 distinct products, and there were quite a few products for which he had visited them or viewed them multiple times. Similarly for the pages viewed. So this gives you a good clear indication in terms of what kind of pages a visitor is looking at, what kind of products he's looking at, and what is the frequency of him seeing a product or a page multiple times. So essentially the idea here is you can do quite a few things with your array with using array in BigQuery. You can get your length of the array. You can find distinct records. You can also get an aggregate view of the array. You can do like different kind of ordering. So you can do different kind of things within the array. Now let's take this a step further. Let's try to query data set that already have arrays. So we'll go back to our query editor here again. And we'll try to query this data. Now, if you see here, again, the query has validated itself. It is going to return 15.9 MB of data. Let's go ahead and let's try to run this data. Hide the editor. So if you see here, we are getting a visit ID, we are getting visit time, we are getting time on site page views. For all other information, even though they are part of the array, they are not available. you get device information, you get browser information. So these are the bunch of information that you're pulling from your array. So if you see here, there are a bunch of fields here which are empty. Not socially engaged, it has engagement time, it has product name. Let's try to get some analytical data from this record. So let's go back to our editor. Bring this guy down. Okay, run this. Let's see what we're getting here. So now if you see here, you're getting an error message. Cannot access field page on a value type array structure. So the idea here that we are facing is uh, to query a repeated field or an array, first we have to break up your array into rows. So let's say, if we have an array which has home page, product type, and checkout, we'll have to create a different row. Now, how do we do that? We can use a nest function. So let's try to see if this works. So we'll go ahead. We'll try to unnest uh, the hits and see if we're able to pull the data out. So we got some data information out. So if you see here, now we have unnested the information on the page title. So we are able to pull this information as an array. So now, up until now, we discussed about how we would go about using array in BigQuery. Now let's take a step further and we discuss about structs and how we can leverage structs in BigQuery. Before we do that, right, we need to understand what a strut is. Strut can have one or many fields in it. It is different compared to array in the sense that your strut can have same or different data types for each field. It has its own aliases. Someone would say that, hey, this looks like a table. So let's dig further and we'll try to find some more information. Let's try to pull some data. So we are not having this public data. So we'll have to pull that data. Let's try to pull some data. So we'll look at BigQuery public data. So now we have this BigQuery public data information. So now if you see here, we have this BigQuery public data information. We'll go and look at Google sample. Let's say if we're able to find the Google sample, where do we have Google? GA sessions. Okay, so we have this information here. Now, if you look at this data, we'll have to find how many structs are available. So it has 2,556 records. Let's go and see how many structs are available here. So let's take a quick preview of the data that we have in there. Let's take a quick look of the preview. Okay, let's look at the schema first. So if we see here how many structs, how many record types are struct. Structs, they have record type as this thing, right? So if you see, you have how many record type count? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 32 struct record types in here. So essentially, if you see here, you are having this struct type as your traffic source. And then again, you have your traffic source dot add word click info as your struct type. So you can have a structure within a structure. Now let's say repeat it. Let's find how many arrays we have here. repeated. Do we have any repeated here? Let's see if we're able to find any array in here. We have a lot of structs here, but I'm not sure if we have any array in here. So for struct, you need to have your type as record. For array, you need to have your type as repeated. So we don't have any repeated here. Maybe one. Now let's say we have session data stored for e-commerce website. The idea behind having struct is that you would have one table wherein you can run your query and get all the data for that particular session without doing any kind of join. So let me explain what I meant by that. So now if you come to your editor and run this query, you see you have this table here. You're having all this information within one table. You don't have to go and look at multiple places to get that information out. And your syntax dot star will tell you to bring all the information within the struct. So instead of doing 32 table joins, you just get one record out which has all the information about the structs. Now let's try to play a little more with the structs. Let's try to create some structs query here. So this is how you define your struct. You say select to create a struct. So you have your runner name Rudisha, and it's a 23.4 split, and it's a struct now. Now let's say if you want to create an array of all the split time here. So you would come here, you would do this, try to run this. See, now you created an array out of it. Now let's say you want to get really run. You want to play around with your JSON data. So you create a new data set. Where's the table? Create a new data set. Let's have it as racing. New table. Created a new data set. Now for this, you create table and you have your table name as your race results. Race results, right? And you ingest this as a JSON file. So you're creating this table. You set up your cloud shell. Now you try to ingest. Oh, You delete this table. Now you create a new table here. Results, you select cloud storage. You try to pull data from cloud storage. JSON, edit as text. So you do your enable edit as text, edit schema. Now go ahead and create this table. So you created this table. You have all this information here. Raise is your string type. Participant is a strut. This is string, and this is repeated. Okay. Now let's try to get some data out from the struts. So if you see here, you have array elements. Number of record written was 1. And you have written different arrays and structs here. So now let's try to run this thing. So here what is happening, if you see for this array, right, cannot access fill name on a value with type array strut this thing. And the issue here is when you have an aggregate function, let's say if you forget a group by, you have some kind of challenges. Similarly here, one of the row for race had 3 rows for the participant name. So how do you change this, right? We'll have to do cross join here, but so let's try to do cross join and see how this thing works now. So we'll close this. We'll go back here and we'll do a quick cross join. If you see error here, it says table name participants missing data set, while no default data set is set in the request. So let's try to set default data set in the request. Now let's try to run. So if you see here, you have all this information, you have your race and you have your name. So now we are able to run the query. Now let's try to add some aliases and replace cross join words here. See, again, you get the same data out. So the idea here is a struct is a simple container of different kinds of data fields, which can be different data types. So let's say if you want to write a query to count how many racer cars were there in total. Right, so let's try to find this question. See, we quickly got this information here. Same. Now let's try to find it by using a different query. Now you are not nesting it, you're unnesting it. It will just give you the counts. Earlier it was not giving you the counts. Now let's try to play around with some arrays. let's try to get this right. See, now you're getting this information out because you're trying to unnest the participants. If you're not doing unnest, you won't get your participations information out. Let's try to see who had the fastest sleep here. Kipketer, 23.2. So with that, we complete our demo here. So the essential part to understand here is BigQuery, although it supports standard structures, you can also add complex structures like arrays and struts into your BigQuery. Now, what is the benefit that array and strut would bring to the table? Array and strut, in essence, they would give flexibility so that you don't have to cut across multiple tables to do expensive joins, or you don't have to create a duplicate records here. Instead of that, you can create one element, one row. You can add multiple different elements of an array. Similarly, you can create a struct which can embed a struct within a structure. And how do you differentiate within a structure and an array? For an array, you would have repeated as your type because you have elements of the array that are being repeated. And for struct, you would have record because struct itself, it's a unit, it's a record for storage. So that's how we should go about thinking about structs and arrays in the big data BigQuery from the BigQuery perspective. With that, I would like to conclude the demo. If there are any other questions, I'll be more than happy to answer. Thank you.